Hello, welcome back to one more video about an econometric topic, regression. In previous video, we discussed some of the basic concept about regression. What is regression? Then what is conditional and unconditional mean? PRF, PRL, then linear PRF, then stochastic specification of PRF, then sample regression line and function SRL and SRF. Then what is the aim of the regression, or what is the fundamental objective of the regression? It is nothing but to estimate the PRF, but the PRF is not directly observable. So we use to SRF, then estimate the SRF, then we infer what is the PRF. Okay, so that's the fundamental aim of the or fundamental objective of the regression analysis. Okay, so in this lecture, in this video, what I am going to discuss with you is some of the very basic concepts about simple linear regression model. Okay, so before going to regression methods or regression modeling, we need to understand certain concept. Okay, that's we are going to see in this video. So let us discuss the first of things. The first thing is, what is a regression? What is SLRM, simple linear regression models? Okay, SLRM is nothing but it is a regression equation where there will be only one dependent variable and one independent variable. Okay, or simply we can say that a regression model with only one explanatory variable is called a simple linear regression model, or what we call two variable regression model. Okay, so a two variable regression model will look like yi is equal to beta 0 beta 1 xi. Okay, so why I am putting yi here? Because I am dealing with cross section data. Okay, so if I put yt, then it means that I am dealing with time series data. Clear? Yes. Then as I told you before, this equation is a deterministic equation. Okay, or this equation tells us the exact relationship. Okay, so if we know the values of beta 0 and beta 1, we can certainly determine the value of y for each value of x. Okay, but as I told you before, the deterministic relationship will not exist in economic relationship or statistical relationship. Okay, this you can clearly understand if you just plot this data in a scatter plot. It suggests that for each value of x, there could be many different values of y. Okay, so for each income groups, there are different values of y. What does it mean? Even though the income level are same, the people consumption patterns are different. That's why we are saying that this relationship is not exact, or this relationship is not deterministic but inexact. Okay, so what we have to do, we will add a stochastic error term. So our equation will be yi is equal to beta 0 beta 1 plus beta 1 xi plus ui. So this is the simple linear regression model or regression equations. Okay, then in this equation we are using certain notations. Okay, what is this y is, what is beta 0, what is beta 1, what is xi, what is ui? All these things we will discuss in detail in this video. Okay, so the next thing is, what is this y? Our equation starts with y. Yi is equal to, what is this yi? Yi is a dependent variable or explain variable, predictant variable, regression variable, response variable, or endogenous variable. All these are same. All these are all some of the name of the dependent variables. Dependent variable, explain variable, predictant, regression, response, endogenous variables. Clear? Okay. So in some book you can see that they have used the term explain and explanatory variable. Okay, in some book they have used predictant or regressor and regressant. Okay, so you have to understand that whatever they have used, if you are seeing all these things, then you have to understand that it is nothing but a dependent variable. Clear? Yes. Now this dependent variable y is a random variable. Okay, so I hope that you have read the material that I have provided. What is a random variables? Okay, so y is a random variable. It can be measured on 4 different scales. This variable, what is our y? Y is a consumption here. Okay, so a y or a dependent variable may take 4 scale. There are 4 measures of scale or scale of measurement in statistics. Okay, so these 4 different scales are depends upon or is based on 4 criteria, or broadly there are 3 criteria and we can add one more criteria, so there will be 4 criteria. First one, whether the ratio of 2 values in this variable has meaning or not, or whether a ratio of 2 variable has any meaning or not. What is ratio means? A value divided with another value. Okay, so that's our first property or first condition. Okay, the second condition is whether the distance between 2 variable has any meaning. What is distance means? Just subtract. Okay, yes. The third thing, whether we can order these values in any of the order or ascending or descending order. And last one more thing is there, whether there is a meaningful zero exist or not. First, whether the ratio has any meaning. Second, the distance has any meaning or not. 3, the ordering is possible or not. 4, meaningful zero is possible or not. Okay, so if a variable is there that satisfy all these 4 criteria or conditions, then such a variable is known as purely quantitative variable, or what we call ratio scale variable. Let me take an example. GDP. Okay, what does GDP means? What? GDP, your income, your consumption expenditure, all these things are ratio scale variable, because if you subtract a GDP figure with another GDP figure, what you will get? You will get a value, isn't it? Yes. Then if you subtract a GDP value from another GDP value, you will see the difference. Okay, then you can say that in a particular year the GDP is less than that of the previous year. You can order the GDP. Then sometime there may be a zero may be possible. In GDP case it may not be possible, but if you take the income levels, then the zero may be possible. Clear? Yes. So if a variable that satisfy all these criteria, then such variable is known as a ratio scale variable, or it is known as purely qualitative variable. Is it okay? Yes. The next one, interval scale variable. What does mean by interval scale variable? Interval scale variable, the second and third properties are only meaningful. The first and the last property doesn't exist. Such variable is known as interval scale variable. For example, the temperature level. Okay, so in Malappuram district, the temperature is 31 degrees Celsius. In Calicut, it is 29 degrees Celsius. Okay, you divide these two. What you will get? You will get some number, but it cannot be interpreted. It may not give any meaningful idea, isn't it? Yes. So, or you take year. Year is a variable. Okay, 2020 is the present year. The previous year was 2019. You divide 2020 to 2020 divided by 2019. What you will get? You won't get anything. Clear? But the distance has meaning. What is that? Malappuram district 30 degrees Celsius, Calicut 29 degrees Celsius. What does it mean? Malappuram is hotter than Calicut by 1 degree Celsius. It has a meaningful. Okay, then 2020 minus 2019, 1 year. The duration in between 2020 and 19 is 1 year. You will get a meaningful idea. Okay, then the ordering is also possible. Malappuram is greater or hotter than Calicut. That is the ordering. Okay, or 2020 is the newest year than 2019. So ordering is possible. So these two conditions, the distance has meaning, ordering is possible. Such kind of a variable is known as interval scale variable. Is it okay? Yes. Then coming to ordinal scale variable. What is ordinal scale variable? Only the third property is meaningful. All other properties will not exist. Take the case of your grade. Your grade is look like A, B, C, D, E, or A plus, B plus, C plus, something like that. Okay? You divide your grade is A plus. Another person grade is B plus. Okay? You divide A plus divided by B plus, what you will get? Or A divided by B, what you will get? You won't get anything. A minus B, what do you get? Nothing. But you will get that, you can say that A is greater than B. Okay, similarly, take the different types of soft drinks, Pepsi, Coca-Cola or Mirinda, 7-Up, like that. Pepsi divided by 7-Up, what you will get? Nothing. Pepsi minus 7-Up, nothing. But Pepsi is better than 7-Up, you can say, or 7-Up is better than Pepsi, you can say like that. Okay, but here the third property is only meaningful. Okay, the last one is nominal scale variable. The peculiar feature of this nominal scale variable is it won't satisfy any of this condition. Okay, it won't satisfy any of this condition. The distance has not meaning. Ratio will not work. We cannot order it. 0 may not exist. Okay, you take the gender, male female difference, or male female. Male divided by female, what you will get? Nothing. Male minus female. Male is better than female. A male is greater than female. No. Then male is 0. Nothing. Okay. So if all those properties are satisfied, it is purely quantitative variable known as ratio scale variable. Just opposite of this, exact opposite of this. 4 of those properties are not meaningful, called purely qualitative variable. Okay, so nominal scale variable. In between these two, certain cases that is qualitative but not purely qualitative. Such kind of variable is known as interval scale variables. Okay, sorry, if as such variable is known as ordinal scale variable, and there are some variable that is not purely quantitative but it is quantitative. Such variable is known as interval scale variable. Clear? Yes. So this is the nature of their y variable. Okay, y is dependent variable. There are so many names for that. This dependent variable will take any of these 4 variables, but in our cases, in consumption cases, it is the ratio scale variable. Okay, so this y variable not only take this ratio scale variable, but it will take interval scale, ordinal scale and nominal scale variable. Clear? So we will see the examples later. Okay, so the next thing, what is the probability distribution of this y? Okay, so this y is a linear function of u. Okay, y is a linear function of u because y is a function of x plus u. Okay, so it is a linear function of u, and since ui is normally distributed, that we will see later. Okay, the error terms are normally distributed, then this yi is also normally distributed. Okay, this we will see later. Okay, so in the previous, now I have given you one material. In that material I have shown you that I have given what is the random variable, what is the property of the mathematical expectation, variance, covariance and all. Okay, so I am using some techniques from that material. Okay, here what is the expected value of yi? Here we have our equation is what? Yi is equal to beta 0 plus beta 1 xi plus ui. Take the expectation of this, find out the average of this. So this would be, say, expectation of yi is equal to expectation of beta 0 plus beta 1 x plus u. Okay, then as I told you before, this equation is consists of both deterministic part and non-deterministic part or stochastic part. Okay, u is the stochastic part and beta 0 plus beta 1 xi is the deterministic part. Okay, then since the expected value of ui, that we will see later. Okay, since the average value of ui is always 0, so what will be left in our equation? Expected yi is equal to expected beta 0 plus beta 1 x. Okay, then since the expectation of a using some of the properties of the expectation, we can write expected value of yi is equal to beta 0 plus beta 1 x. Okay, for that how we got this expected yi is equal to beta 0 plus beta 1 xi, you see the material. Okay, yes. So coming to the weight, so what is the expected value of yi is equal to beta 0 plus beta 1 x. Okay, then what is the variance of y? Variance of y can be written in the form of expectation. Okay, so variance of y is equal to expected yi minus expectation of y whole square. Okay, so we know that what is y here? Yi is equal to, y means what? Y means the total equation beta 0 plus beta 1 x plus u. What is expected y? Expected y we got just before, beta 0 plus beta 1 x. You subtract it, then what left in this equation? Only u will left. So it will be variance of y will be equal to expected u, then square is remain there, so expected ui square. Okay, so this will be our variance. So the variance can be written as small sigma square. So variance y is equal to small sigma square or expected ui square. Clear? So this y, what is the expectation of this y? Beta 0 plus beta 1 x. What is the variance expectation of ui square or small sigma square? Okay, so what I am trying to say at, this dependent variable y is normally distributed because y is normally distributed with beta 0 plus beta 1 x as the mean and small sigma square as the variance. Clear? Yes. Then coming to the x. Okay, so in our equation y and x are variables. Y is dependent variable, x is independent variable or explanatory variable. Okay, so we have discussed about dependent variable. Now we come to the independent variable. Okay, so x is called independent variable, explanatory variables, predictor variable, regressor, stimulus, control or exogenous, just opposite of the previous one. Okay, where we find explain variable, here is explanatory variable. Dependent variable, independent variable, predictant variable, predictor variable, regressant, regressor, then stimulus or control variable. Then earlier we discussed endogenous. Here we have, so earlier we have discussed response variable, just opposite of that stimulus variable, then exogenous, endogenous variable. Okay, so all these are all the same name. That is denoted for the explain variable or explanatory variable or independent variable. Okay, so I hope that you understood what is independent and dependent. Okay, dependent means what? This variable y is dependent for something. Okay, just example, y is a function of x, y is sorry, consumption is a function of y. Consumption depends on y and y is independent of consumption. What does it mean? Whenever your income increases, your consumption will increases. But whenever your consumption increases, it may not increase your income. Okay, so consumption is depends on income, but the income is independent of your consumption. Whenever your consumption increases, it may not increase your income. Clear? Yes. Okay. In classical linear regression model, it is assumed that the independent variable x is not random. Okay, so y is a random variable, but x may be a random variable and may not be a random variable, and this variable can also be measured on for different scale. Okay, then in classical regression model or in regression model, we are assuming that these values of x are fixed in repeated sampling as a result of the regression analysis is conditional upon the fixed values of the regressors. Okay, so since earlier we have seen that this the x is the income level is same 80. Okay, there are 5 different households, they are having the same level of income. Okay, so here this income is fixed for different households. Okay, that's why they're saying that sometimes it may be assumed that the x may be fixed, okay, in repeated sample. Okay, so more about this thing we will discuss when we discuss about the assumptions of regression analysis. Okay, yes. Then coming to the nature of the y or nature of the u variable. As I told you before, stochastic disturbance term or error term is a variable, is a surrogate for all variables that are omitted from the model but they collectively affect y. It's a variable or it's a group of variables, okay, that is included in our model because it will have a collective effect on the dependent variable. Okay, for example, in our consumption function, y consumption is a function of income. Apart from income, there are some factors. Okay, that someday it may be measured and someday it may be not measured or listed or not listed, no problem. But individually they may have a very negligible effect on y, but collectively they may have some effect. Okay, so such a variable is known as, so instead of such a variable we are putting a term u. You will collect all the, what is the total effect of this unobserved variable. Clear? Yes. And why we are including this error terms? There are large number of reasons for that. Okay, so when we discuss about the methodology of econometrics, we discuss some of these variables. Okay, the first one is all those variables that cannot be readily quantified. There are certain variables that we cannot readily or exactly quantify. So what we do, we will omit that variable and instead of that variable we will put you will capture this effect. Okay, then in some time the data may not be available. For some variable the data may not be, or clear exact data may not be available. In such situation what we do, we will remove that unavailable data variable, then don't worry about it, the u will capture it. Okay, then errors in the measurement of the data, the model misspecification and functional misspecifications. Okay, suppose if we commit some mistake in specifying our model, or we take incorrect specification for something. Okay, what is incorrect specification? What? Okay, so in estimating a cost curve, average cost curve, what we have to do, we need to specify a quadratic function. Suppose instead of that we specify a linear function, we committed a mistake. Okay, so this type of a mistake will take care by this u. Okay, then intrinsic randomness in human behavior. What is the intrinsic randomness in human behavior? Is what this says, that human behavior are not predictable. Even though there are 10 members in the same family, all these 10 members will be behave differently. Similarly, if there are 100 people, some fellow has given this 1,000 rupees for all these 100 fellows, 100 people, okay, and he said them to spend it. All these 100 people will spend this 1,000 rupees differently, because human behavior are unpredictable. We cannot predict. Okay, this is what we know as intrinsic randomness in human behavior. Okay, human behaviors are different or unique for different individuals, that we cannot predict or that we cannot model. Okay, so in order to include such kind of behavior, what we have to do, we will put you will take care such kind of intrinsic randomness in human behavior. Okay, then poor proxy variable. What is poor proxy variable means? There are some, in certain cases, the exact variable or exact data may not be available. For example, you take the case of India. If you want to measure, or if you want to verify Keynesian liquidity preference theory, the theory says that the demand for money is positively related to income and negatively related to interest rate. If you want to verify this theory for India, what we have to do? We need money supply data. Okay, we need income data. GDP is there for income. We know that GDP is just a proxy, not an exact figure for measuring the income level. Okay, then we need interest rate. For India, we don't have a unique interest rate. We have a different series of interest rate. So which interest rate we will take? Sometimes we can take the treasury bill interest rate or carbon interest rate. Okay, so all these things, in all such kind of things, we don't have a proper proxy or proper variable. Instead, what we have to do, we are having, or we will take some proxies. Okay, these proxies may not capture all the things perfectly. Okay, so for accounting such mistakes happening in taking the proxy variable, don't worry about that, thus you will capture it. Okay, and last one is the principles of parsimony. What this parsimony says, or parsimony principle says? Parsimony principle says that the equation should be simple as possible. The economic model should be simple as possible. Okay, suppose there are in consumption equation, there are large number of variables that will affect our consumption. Okay, there are 10 variables, 15 variables. We cannot take all these variables. Our equation will be very large. So what we have to do, we have to reduce the equation, or we have to adopt principles of parsimony, or the equation should be simple as possible. For keeping the equation simple as possible, what we have to, you remove certain insignificant variable, then include u in the equation. Okay, yes. And sometimes the theory may be vague. Okay, in that case also we can rely on this error terms. Okay, so these are all certain reasons for why we are including error term in the equation. Clear? Yes. Now, so far we discussed y, x, u. Okay, some things are left there. Okay, beta 0, beta 1. What is this beta 0, beta 1? Okay, so in classical linear regression model framework, the main idea is, okay, this variable or these parameters beta 0 and beta 1s are fixed numbers and not random numbers. Okay, but even though we don't know the actual values of this variable will be a fixed value for all people. Suppose there are 60 members in our equation. Okay, but if we, how many beta 0, beta 1 values will be there? Only one. Okay, because this beta 0, beta 1 will tell us the average. Okay, so there will be only one figure for that. Okay, and our aim is to measure this unknown fixed non-random parameters. In regression, what's our aim? To estimate or to find out the unknown values of beta 0 and beta 1 from the known values of y and x. Clear? Yes. Then why I am used beta 0 and beta 1? Why cannot use A or B, something like that. It's up to you. Okay, so in econometrics what we are actually doing is we are denoting the coefficients or parameters using Greek letters. In econometry you can see that they have used the Greek letters. Okay, they have used Greek letters, so that's why we are using Greek letters. And if you are any problem with Greek letters, then don't worry, you can use A, B, C, something like that, that also you can use. Okay, so what I am trying to say that in many books they have used many coefficients. Okay, so in our classes what we will use alpha, beta, or beta 0, beta 1, beta 2, something like that. Okay, but in some book they have used alpha, beta, theta, gamma, lambda. Okay, then pi, tau. Okay, but these are all certain Greek word or Greek letter or Greek alphabet. Okay, that have used only to denote a coefficient. Okay, so these are just an alphabet, don't confuse with that. If a book has used beta 0 and some book they have used theta, both are same. Okay, the shape of this letter won't tell anything, but the idea of this equation will give us the will give you the idea. Okay, not this the shape of this alphabet. Clear? So these are all some of the Greek letters. If you don't know this Greek letter, you have to learn this. Okay, alpha, beta, gamma, delta, epsilon, zeta, eta, pi, then theta, lambda, mu, pi, rho, sigma, tau, omega. Okay, these are all some of the Greek letters that we use regularly in our teaching or in our learning process. Okay, so please understand what all these what is the shape of these letters and how to pronounce these letters. Is it okay? Yes. So I think we have explained all the notations related to simple linear regression model. We explained what the equation is all about. Okay, then what is dependent variable, the scale of the dependent variable, then the distribution, the probability distribution of this y, what is the expectation of this y, what is the variance of this y. Then we have seen the explanatory variable or independent variable, then error terms, reason for error terms, then we have seen parameters or beta 0 and beta 1. Okay, so these are all about this today's lecture or today's video. Okay, I hope it is understood, and if you have any doubts you can contact me. Thank you.